and I want to fill in this space with what we just did. So on the left side it says general equation for cosine. Here it's going to say a more accurate model. And specifically, this is, actually we should just call this combining functions. Okay, now I'm going to use the example of what we just did, the exponential with the sinusoidal. So, I'm going to do this graphically because I think you'll be able to see it better. Say we have a sinusoidal function that looks like this, and then we have an exponential function that looks like this. So you have your sinusoidal. And we also have our exponential. We have equations for both of these. And we'll just use cosine in this case. And then your exponential, we'll use the term m again. And I'll just use x up here plus k. Okay, looking at these two equations, what letters, or what do they have in common? Well, A is in common. You know what? To make your life a little bit easier, I'm going to take out the A, because we're not going to have the A on this one. What other letters do they have in common? K. And that's really what kind of makes them have a common thread. K is their midline. So K is your midline here. And then the exponential function, it's not your midline anymore. What is it? It's your asymptote. All right. So we know that the k's are in common. Now the combined form of this looks like this. Y equals A times m to the x times cosine b to the x plus k, b times x to the k. We're going to look at each part here. So let's do the sinusoidal first. I'm going to color code this. So here's your sinusoidal and your exponential is this. So again, you have an exponential sinusoidal function. Alright, that's the two forms together. And if we were to look at the final graph of this, what it looks like in the end, is you have a sinusoidal function that is decaying over time. This remains k, and you can see that your amplitude is shrinking.